So like funny story about this. There's always one question every year on the AP test that relates to hybridization, okay? Last year, because of the timing of when we did this unit, we rushed through chapters 8 and 9 last year, so they didn't really get as good of a background on it as you're getting. We never discussed hybridization because I was like, it's a one-question topic. Who cares? If they miss the question, they miss the question. The night before the test, we all got together for a review, okay? Somebody asked it because it was in their Princeton review book, and they were like, what is hybridization? And I was like, all right, I'll take 5 minutes to give you the information you need to answer the one question that will come at you about this. If you get it, great, you'll get the point. If you don't, you won't. It turned out to be the very first free response question. So Sierra's like, yep.
I got that one.
You did?
Yeah.
Even though you weren't there the night before?
Yeah.
Oh, good.
I remember the 5 minutes. You were like, you really only need this, this, and this. And then I remember it.
Yeah. Yeah.
It was so easy.
Yeah. So it's like they spend 15 slides talking to you about it, which some people really enjoy. So some of you might want to actually like read through these and understand it in more detail. I don't need to do that, okay? Well, because some people actually like to understand the why underneath it to really, some people don't. It's a personal preference thing, okay? But here's what I will ultimately tell you, okay? So give me a second. Let me find, all right, like on this slide, for example, okay? When we are talking about molecular molecules and their covalent bonds, they are sharing electrons. What that actually means is that their orbitals are overlapping, okay? So like the 1s, 2s, 2p stuff that you learned, what's actually happening is when H2 forms, the 1s orbital of one of them overlaps with the 1s orbital of the other, and their orbitals share space, which is how that electron is able to be with both. Does that make sense? Okay. Was that a real wow or a sarcastic wow? Okay. HCl, same thing. Chlorine wants that electron in 3p. Hydrogen has it in 1s. The 1s and the 3p are going to overlap. ClCl, their 3p orbitals are going to overlap. Okay, so that gives you a little bit of visualization there. We're going to come back to this next class, but I'll give you a little preview right now. Please keep in mind that it's electrons overlapping, and electrons are negative, and they repel each other. There is an ideal overlap, okay? Too close, too much overlap, they're going to repel, okay? Too far away, they're not going to be able to share. You know, so there is a balance to this overlap, which we will talk about, okay? But what you really need to understand is that when the orbitals overlap, they create hybrid orbitals, okay? And it's referred to as hybridization. Now, the truth is, I can show you all of this, okay? But the bottom line is I can sum it up for you really, really easily without you having to look at these complicated like nodes and lobes and things like that. Like these pink and purple and blue shapes don't help me. Maybe they help you, but I don't know. Okay, so here's what we're going to look at. If you have, for example, and this is really all you need to know, okay, because this is all they would ask you. So bear with me here, okay? If you have a molecule like Be, not good timing. Not good timing. This is Dr. Peacock. Hi. Yes. You're welcome. Bye. Oop. Your internship stuff is with Miss Lewis. Okay. Okay. So if you have a linear molecule, okay, and the example they use is BeCl2, although it's not a great example, but I'm going to use it anyway. Okay. How many orbitals do you have overlapping? Like 3 things, or well, you have 2 areas of overlap. Correct? Are you with me there? 2 areas of overlap is called SP, hybridization. Okay? So, what shape do you see up there? Starts with an L. What shape? Linear. So linear molecules make SP, hybridization, because there are 2 areas of overlap. Okay? S and P. S1, P2. Got it? Now, I'm going to draw like BF3, for example. BF3. What shape is that? Trigonal planar. How many areas of overlap do you see? 3. That is called sp2 hybridization. S1, P2. That's 3 areas of overlap. Trigonal planar. Trigonal means 3. sp2 hybridization. Are you with me there on how I remember this? sp2. 3 areas of overlap. Trigonal planar. The trigonal planar shape always makes sp2 hybridization. Trigonal means 3. sp2, that's 3 letters. Are you with me? Tetrahedral. What does tetra mean? 4. Guess what that's called? sp3 hybridization.
So when is it not? When is it not SP? Or is it always?
Well, here are the 2 others that they might ask about, and the bell's going to ring. Remember our 5 basic shapes. We also have trigonal, bipyramidal. Make sure, by the way, P.S., before that bell rings, you have homework problems in Chapter 9. If you need to take pictures of it, do it. Trigonal bipyramidal makes sp3d. Octahedral, remember that's our other shape. Remember our 5 basic shapes were linear, trigonal, planar, tetrahedral. Octahedral is sp3d2. Okay?
What does D go up to?
Well, that's it, because that's the extent of the expansion you can have. Remember, trigonal bipyramidal means 5 things attached to the central atom. So 1, 2, 3, 4, 5. Octahedral has 6 things attached to the central atom. So that's 1, 2, 3, 4, 5, 6. Got it?
Yes.
We're done with Chapter 9. The classroom quiz you wanted will be available later today. Yay!